Hello guys, welcome you all to this video of Maths Beetle. Here we will discuss about certain kind of problem, namely Laplace equation. And this question what I have picked here, it was also asked in NET exam. By the way, these sort of problems are not very trivial type of question. As you can see here that this Laplace equation is asked with so much of extra condition and student get puzzled with these conditions. Not only Laplace equation, the same kind of formulation can be done with heat equation, wave equation, and so many extra equations are there as well. But there is certain kind of tricks and techniques with suitable approach that you should know to solve such problems in the exam hall. Otherwise these are very difficult to solve in exam hall. So if you are really interested to solve this sort of problem in exam, then you are most welcome in this video and watch till the end. I'm sure that you will get something from this video that will be helpful for you in the exam hall as well. Okay, so without wasting any time, read this problem first of all, think little bit and follow each and every step. And most importantly, if you find anything helpful, then don't forget to share the video with your friends so that it can reach many more students and students get benefited by this channel. So without wasting any time, go in the main part of this video and enjoy it. To solve such problem, we should know that one of the form of general solution of this Laplace equation is uxy. Say uxy, it is the general solution and it will be of this form: summation a cos hyperbolic lambda x plus b sin hyperbolic lambda x into c cos lambda y plus d sin lambda y, where these lambdas are in terms of n that will be cleared after subsequent treatments, and as well as this a b c d, these are constant and all of these constants will get reduced to certain form which will be dependent on n as well. Okay, so this summation will be over n equals to 0 to infinity. This is nothing but property of superposition principle. We will take this one and this concept will help us to proceed further in this problem. Okay, we'll take this general solution as the summation of this hyperbolic functions part and this trigonometric functions part. Fine. Now we will use the first condition which says that ux0 equals to 0. That means you put y equals to 0 and you get ux0 equals to 0. That immediately implies this part, from this part you will get c equals to 0, correct? And another condition which says that u0y equals to 0. That means put x equal to 0 and it will give you 0. That means this part, from this part, look at a will get equal with 0, correct? That means your solution, general solution will be of this form: some constant, say e sin hyperbolic lambda x into, here comes sin hyperbolic lambda y, it is not hyperbolic, sin lambda y, and obviously n equals to 0 to infinity. Till now we have no expression for lambda in terms of n, but we will get it now. Look at, up to this I think clear, nothing special. Okay, now we are going to use this another condition which is u at I think x comma pi equals to 0. This is another condition given to us which will imply, look at, sin lambda pi equals to 0. that implies lambda pi equals to n pi, that immediately implies lambda equals to n, correct? So finally this transforms into the equation of this form: E sine hyperbolic, here comes nx into sine ny. We have a constant en star, and which is just a enumeration. Okay, so finally we have uxy equals with this expression, correct? Okay, now we are in a position to use the last condition, which says that u I think pi comma y, it is given as sine y sine 2y. Here it is 0 less or equal to y less or equal to pi, fine. But we have uxy as summation en star sine hyperbolic n, I think it is nx, no? Yes, nx into sine ny. N from 0 to infinity, there is no meaning of n equals to 0 because it will get into 0. By the way, u pi comma y, it will give us en star sine hyperbolic n pi sine ny, n from 0 to infinity. Okay, now this is sine y sine 2y, and here e0 into 0, no effect, e1 obviously it is star sine hyperbolic pi sine y plus e2 star sine hyperbolic 2 pi into sine 2y plus e3 star to something, e4 star into something, and so on. So we can compare both sides, and immediately it is clear that obviously this first term will be equal with 0, nothing special, but e1 star will be 1 by sine hyperbolic pi, e2 star it is 1 by sine hyperbolic 2 pi, fine. Okay, and remaining e3 star, e4 star and so on, all are equal with 0, correct? That means our solution uxy, it is going to be e1 sine hyperbolic x plus obviously into sine x sine y plus e2 star sine hyperbolic 2x into sine 2y plus e3 star into something and so on, but e3 e4 star, all these values are equal with 0, so this is going to be our general solution. Plug the value of e1 star and e2 star and you will get sine hyperbolic x sine y by sine hyperbolic pi plus sine hyperbolic 2x sine 2y by sine hyperbolic 2 pi, correct? Fine, we are all set to tackle the options. First of all, in the option 1, they are claiming that just for your comfortable, I'm dealing the questions or dealing the options here. First option, it says that u 1 comma pi by 2, 1 comma pi by 2, what will be the value? Just plug here and you will get sine hyperbolic 1 into sine pi by 2 means 1 divided by sine hyperbolic pi, and plus the remaining term will give you 0. Just do the calculation, and in fact you are getting your first option, hyperbolic pi whole inverse sine hyperbolic 1. This is your first option. And similarly just check it out and you will find that your third option, u 1 comma pi by 4, this will give third option as another correct option. So finally you are getting option 1 and option 3 as the correct options. Fine. I think you got the flavor of superposition principle and how to use the superposition principle to solve such problems. Okay, thank you.